Hello, I'm James Ingram. This is part 2 of video number 814, which showed an NCE DCC mini panel automatically controlling 3HO trains on the same track. Now what this video part 2 will do is review the commands used to perform these different modes of automatic operation. Thanks for watching. Here's a look at the picture of this layout. Out here on the main line, we've got read switch number 14, which we call our go read switch. It's actually sitting right about here in the track. You can see that, maybe see that piece of green tape. And then back in the yard, we have what we call read switch 16, which is our stop read switch. And there's actually two of them. One under each track. Again, you can kind of see maybe the green tape which shows their position, and this is actually two read switches, but they're both wired together to input 16. Now, an important thing to note about this layout is you see this layout has a yard, and then it goes around and up an incline and over top and comes back down. So there's almost two complete loops before it comes around and back into the yard. You need almost this much minimum distance to make this thing run without being too jerky. When I first set this thing up, it looked like this, just a simple loop on the table, and it would, and the read switch number 16, the go read switch, was over here. So when this train crossed this read switch, it released a train from the siding. This worked okay, but the problem was it was too much stop and start. You could run it okay, but it didn't really give a good visual appearance. You needed more main line to make these trains sit here a little longer, which is why I did the up and over incline. If you were running on a table just this size, it'd probably be better just to run two trains. In other words, take this train out of the picture and just run these two trains as an automatic passing siding, where this train would start out and run one or more loops, and then this train would then this train would come back and park, and then this train over here would start out and run one or more loops and come back and park, and then this train would run again. And you could very easily extend this to three sidings if you want to. Three siding was done in large scale, as shown in video number 812. While we're on the subject of layout size, let's take a look at a hypothetical display layout here with some kind of a view block down the center of it. If you have spectators observers over here, what they're going to see maybe is a train going by once every minute, assuming it takes this loco a minute to travel around that loop. Now, if we take that layout and we add an automatic yard to it, we've got something that looks more like this, the same loop, but with an automatic yard added over here. So just as this train may be disappearing around the end of the view block out of sight, we've got one of the other trains coming into sight over here. So instead of one train every minute, we've got two trains going by every minute, making it a little more interesting for the spectators. In addition, because we've got the third engine, that will soon come out, so they'll see three different trains going by instead of just one train. I just want to mention that currently all these files referenced in this video are available on the web currently. If you go to the YouTube page for the video or the Vimeo page, and this shows the YouTube page for part 1, and hit the show more button, it'll show you the description, and in the table of contents, and down at the bottom below the table of contents there's a related links section, and it says use this link to open a directory containing PDF files of the logic diagram, that's what I'm calling the sequence diagram, wiring diagram, and list of commands. So if we click this link, that opens in a new tab, a directory, and you can see there's the wiring diagram is here, the sequence diagram is here, the commands are here. Let's take a look at those real quick. There's the wiring diagram in PDF form the sequence diagram in PDF form, and there's 2 pages. This page is the 3-train operation. This second page is a 2-train automatic passing siding and automatic block operation, the time station stop. And if we go back to the command file, check that link. There's a PDF file of the, I call this the command documentation file. There's a picture and a copy of the wiring diagram and the sequence diagram on the front, but then all these commands are listed that were used for this video, and we'll be discussing all these during the rest of this video, but here's how you find the PDF file with all this stuff. And then finally there's several images in this directory also, like there's one that shows the layout. So just so don't forget that this stuff is currently available on the web as long as the AutoControls.org website is alive. Here's the wiring diagram for this video number 814, and it's fairly simple. It's actually the same components and essentially the same wiring diagram as was used for previous video 812, where we ran 3 LGB large-scale trains. Let's take a look at that briefly. Here's the diagram from video 812. You can see the same components. We had the 2 switch cats, in this case back on the inlet end of the siding, so we could have 3 tracks, and in the discharge end we took the switch motors off and just let these points float, which will work okay in large scale. Now let's go back and look at the drawing for this video 814. What we've got is the power control panel up here, and that's part of the power cab. So if you were using like a Powerhouse Pro or a Smart Booster, you wouldn't have this power control panel. But either way, the input power for the track is over here. These 2 heavy black lines, you can see they come into the terminal block and then out of the track. Now over here we got the mini panel shown here, and our 2 switch cats that are controlling our 2 Kato HO powered turnouts. And over here is read switch 14, which is the go read switch, and in the yard is the 2 read switches which are hooked up to input 16. We're calling those read switch 16 the stop read switch. Now important to note, these heavy black wires are essentially the track bus, and this is NMRA standard DCC. So although these are decoders used here are switch cats, which, as I mentioned, they'll control both either a Kato HO turnout as seen in this video, or they'll control an LGB large-scale remote turnout as shown in video 812. These are made by NCE, but since this is a standard NMRA track bus, you could use probably any brand of about probably 20 decoders, 20 accessory decoders to control turnouts, like for example Digitrax accessory decoders, Lens accessory decoders, Massoth accessory decoders, and so on. Anything as long as they comply with the NMRA DCC standards. Let's take another look at a photo of this layout. Here's our power cab, and over here is our power control panel that's part of the power cab. In here is the mini panel, and over here are the 2 switch cat decoders, and these are on the control board just trying to make this neat. This switch cat was originally out here, but since it was so close to this one turnout, I figured I'd just put them up on the control board to try to keep things neat as possible. And then the wires, these wires running back here, this goes back to the rear turnout, and here's the wires connected to the front turnout to power that. But again, these switch cats could be any place out on the layout. You could have them back here or wherever connected to the track, at any location, since they're running off the track signal. And again, read switch 14 are go switches here, read switch 16 are stop read switches are here. Now this cable here is a 3-wire cable that runs out to the 2 reed switches. There's one wire for ground, and there's one wire for number 14, and there's one wire for reed switch number 16. So that this 3-wire cable is handling the reed switches, and this wire running out here is just the power to the track. Here we are back to the wiring diagram, and I modified this a little bit on the fly since we last looked at it. We've got button 1. Well, here's there's a reset button here that resets the mini panel. Button 1 is connected to connects to input 1, which starts a test routine to test the reed switches. Button 2 is our normal run button. That goes to input 2, and that starts the normal program that operates 3 trains. And then connected to inputs 14 and 16, we have our 2 reeds, actually our 3 reed switches. Our 2 reed switch number 16s, our stop reed switches. They connect to input 16, and reed switch 14, which is our go reed switch, that comes around and connects over to input number 14. Now, an important thing, I recommend positioning this number 14 reed switch approximately 60% around the loop, because you can use delay commands, as shown here. You can use delay commands to adjust the virtual position of this reed switch number 14. In essence, you can effectively move it like it was further downstream by using a delay command. This shows one position here, and this shows a second position here. You can't move it upstream with a delay command. That is just saying, in another way, there is no such thing as a negative delay command. So it's probably better to put this thing a little too far upstream to operate without a delay, but then just use delays to adjust it, and that'll give you the greatest flexibility. Looking at the limits, well, let's go back to the logic. Recall from the video, and actually recall that there's magnets on the bottom of the first cars as shown in this video. There's magnets on the bottom of the first car behind each engine, and when those magnets go over a reed switch, they'll just momentarily close the reed switch, which will notify the mini panel. The mini panel can detect when the reed switch is closed, and that tells it that train is on the reed switch. So the logic is there's these 2 trains in the yard down here. These are stopped, and they're waiting for a train on the main line, which is moving. That's what these lines here behind the engine are trying to show. That engine's moving. Those two engines at the bottom that are stopped, they're waiting for an engine that's moving to go over the reed switch on the main line. Just for a review, here's a section from part 1 of the movie on YouTube. You can see the reed switch. This is mode 3C. You can see the effective position of the reed switches back in the rear, where that arrow is pointing right now. That's back where that green arrow is. Now, the important thing to note when a train gets to that reed switch, it causes one to pull out of the siding, and this is essentially mode 3C, where we keep 2 trains on the siding as long as we can, and we move the reed switch effectively as far downstream as we can. It's over here. Now, the important thing to note is our actual reed switch position of number 14 is up here, but we've got about a 15-second delay in there. Now, remember, this is speeded up 500%, but it's actually 15 per second delay between here when the train goes over the reed switch and when it goes around to the rear where that green arrow is, when it effectively releases a train from the siding. So as the mini panel is programmed in this video, when this engine on the main line, the orange engine, crosses this reed switch wherever we have it activated using our delay statements, it'll set the turnouts to curved, and it'll start up the blue engine, which will leave the siding. Meanwhile, the orange engine will be coming around the main line and come in and come in that vacant siding, and when it goes over the red reed switch number 16, the mini panel will send a command to stop the orange engine, which will drift in and stop about where the blue engine is shown. So meanwhile, the blue engine is out on the main line, and it'll cross the green reed switch, and again, wherever we actually send the commands, the mini panel will set the two turnouts to straight, and then it'll send a command to start up this purple engine, and the blue engine will then come in the straight turnouts and stop on go over the red reed switch, and the mini panel will send a command which will stop the blue engine on the outside track. So these engines are continuously sequencing and changing on different tracks. Now let's talk about the position of this reed switch again. If you put it here physically, but you can use delay statements to move it downstream, you've got to move it downstream enough that this train, when it's going in the siding, gets across this red reed switch before the blue train gets around here and goes over the green switch. They got to stay in order. And also the orange train's got to get in and get the caboose across the turnout before the turnouts are thrown to straight, or you'll have a derailment. So that's kind of the extreme limit, moving this thing upstream. Now moving it downstream, you can go downstream pretty much, and when you move it upstream, that's what we called mode 3B in the video. Mode 3B, we kept two trains running on the main line as much as possible. Now moving it downstream as much as possible, we'd be getting to what we called in the video mode 3C, where we had one train running most of the time and two trains parked most of the time. And you can see if you keep moving this thing down toward the turnouts, this orange engine will have to travel further and further before it sends a command to start the blue engine up. And when you've gone too far, the orange engine will be coming down here and practically coupling up to the back of the blue train. So that's the limit on the other way. And you can basically just experiment with these and see what you like best. One more comment about cabs. This drawing shows the power cab over here being plugged into its power control panel, and this could also be replaced by a ProCab and a Powerhouse Pro, or also I believe a ProCab and a Smart Booster. But theoretically, I think you can do all this with one cab, but I think it's easier to have two cabs. In my case, I've got a old ProCab that I plug in the programming port when I'm doing programming, and that way I can use this cab for programming and have this cab available to turn on and off lights or sound or whatever. In the particular case of this video, there's so many commands in the mini panel, the thing is full of commands that there's actually not enough buttons to operate. I think there's 5 different little routines in the mini panel, and only one of them is, 2 of them are accessed by buttons 1 or 2, but the other 3 routines, there's no available space to hook up a button. So we're using the ProCab in running the thing in test mode with the thing in the program mode. Here's what we call a sequence diagram for 3 trains. This is probably the key diagram for making this video. I had to sit down and do this before I could actually figure out how to put the commands in. What this shows here, it breaks down into 6 parts. You can see there's on the left here is parts 1, 2, and 3, and over on the right is parts 4, 5, and 6. It breaks down to what I call 6 sequences before it starts repeating again. And this is the same as seen in the 1992 videos, V9202 Module 10D and V9202 Module 10E, which show LGB trains running on a similar system but using LGB switch motors and plug-in double pole, double throw relay points to make an electromechanical relay system. But now here in 2016, we're doing the same thing, but we're using mini panel commands to achieve the same type of operation. So here's our startup. Here we've got these two engines sitting in the siding stopped, and our orange engine is on the main line. So when this engine crosses reed switch number 14, what we want to do, we say we have a command that says wait until number 14 is ground, and then when the magnet on the car behind this engine crosses the reed switch, that'll ground it momentarily. And when that happens, we'll send commands to set the turnouts curved, and we'll start engine 1216 up, which is this blue engine here. So the second part of this sequence, now that the blue engine is started, it'll be out of the siding on the main line, and this orange engine will be coming into the siding, and that's shown right here. And the next thing we're waiting for to happen, we say wait until input number 16 is ground, and that's this reed switch here, the stop reed switch, and then we'll send a speed command 3364 equals 0, which stops the orange, sends a stop command to the orange engine, so it'll basically coast to a stop under its momentum, and at that point it'll look like what we see in 2A, and then we're going to have the same set of commands all over again, just with different engine numbers. At this point, engine 1216, the blue one, is approaching the go reed switch, so we say wait till input 14 is ground. When that engine's car with the magnet crosses over it, then it'll set the turnout straight, and it'll send a speed command to start up engine 051, which is this purple one down here. So that'll start that up, and let's get down here and look at it. At this point, the purple one has moved out onto the main line. Our blue one has come into the siding, and here's the second half of that sequence. We're going to wait till input 16 is grounded. That's the stop reed switch. Then we're going to send a speed command to 1216 of 0, which is the blue one, and it'll drift to a stop and park on the siding. So at that point, we'll be down here to this sequence, and again, it's starting to repeat, just different engine numbers. The purple engine's approaching the green reed switch, so we'll say when that happens, set the turnouts to curved, start up the orange engine, which is this engine here. So the second half of that, this engine, purple engine's coming into the now curved turnout siding, approaching this reed switch. We'll send the commands when it crosses this reed switch to set its speed to 0, so it'll drift to a stop. Then going up here to sequence 4A, and we're really halfway through the cycle at this point. You can see we got the same two engines stopped on the sidings as we had at the beginning of the cycle, except they're reversed. The purple one's on the inside and the blue one is on the outside. And we've got the orange one again approaching the reed switch 14. So when it gets there, we're going to say set the turnout straight, start the blue engine up, which will be this one. And I put these dotted lines around each engine, and I said the circle indicates next loco to leave yard. It was easier to keep track of that if I had a visual indicator of which loco was going to go next. But at any rate, when that orange engine comes in the siding, it'll look like this, and we're going to wait till it goes over the stop reed switch and send a command of speed 0 to this orange engine, which will cause it to drift into the siding and stop. And that brings us down to subsequence 5. These two engines will be parked and the blue one's on the main line. And again, we'll wait till it crosses over the reed switch, say set the turnouts curved, and start up the purple engine, which is this one, again indicated by the circle. So that one will start out of the siding. Coming down here to the second half of that subsequence, the purple one's out on the main line, the blue one is coming into the siding, and again we're going to wait till the reed switch 16 is crossed with the magnet, then send a set speed 0 command to that engine, which will cause it to stop deaccelerating and stop on the siding, which will bring us down to here, the last subsequence of our sequence, so to speak. At this point, the purple engine's on the main line approaching read switch 14. And when it crosses that, we'll say set the turnout straight and start up the orange engine, which is this one. And coming down here to the second half of that subsequence, our orange engine will be on the main line running. The purple one will have come into the siding, approaching the stop read switches. And when that happens, we're going to say set its speed to 0, which will cause it to drift to a stop. So when all that happens, now we're back up to subsequence 1A and starting everything over again. So I basically used a cruder version of this drawing to rough these commands in, just like you see them here. So what we can do now is take these abbreviated commands and actually put the commands in write down the commands that we need to put in the mini panel. Here's a copy of the command file for this video. In the front of it, there's a copy of one of the pictures, and then a copy of the wiring diagram, and a copy of the sequence diagram. And then on page 3, we actually get into the commands. The first thing that's documented here is the configuration memory of the mini panel. And you normally don't change this too much, but it's important to get it set up properly. Over here is shown the defaults, and we're basically using the defaults except for memory address 3, which is continuous memory, where the default's 0, I believe, and we're putting a 1 in there, and that means all the memory will be continuous. It'll go from one input to the next input as a program executes. If you don't have continuous memory, then it only executes 4 steps at a time. Then you have to use a link statement to go to the next step. I looked at one of the NCE examples on their NCE website, and they set it up this way, and it seems like the logical thing to do. It's just set all the input locations to continuous memory. Now the next one, memory address 4, this is important also. The default is 0, and we've set that to 3, and that means it's disabled the inputs 3 and above. So it'll check inputs 1 and input 2, where we have our 2 push buttons hooked up, but it won't be checking normally inputs 3 through 30, the rest of the inputs. Now it will check them if they're specifically referenced in a command, like we have a wait until input 14 is grounded, or wait until input 16 is grounded. We use those 2 commands, so it will check inputs 14 and 16 if specifically asked to, but otherwise it won't check them. Down here is that engine settings. This just keeps track of acceleration and deceleration and speeds, and of course this is specific to the engines used in the video here. Now on next thing, talk about, I made what's called a command library. The mini panel instructions come with sort of like a tree, and you can go through that tree and build your commands. But what it actually works down to is you're punching certain numbers. So copying how Fred Cupp did it, I make an entry table. That's what this column is showing here, and these show the actual numbers that we have to enter a certain command. And it turns out the things done in this video just use about 11 different commands. And like I say, we called this the command library. And the number in red is a number that normally changes, but the rest of the numbers normally stay the same. So let's just review these commands quickly. We got to delay a quarter second, and if we use a 4, that means delay a quarter second times 4, which is a 1 second delay. Then similarly, there's a delay 4 second. If we ask for 2 of those, that'll give us 4 seconds times 2, which results in a delay of 8 seconds. So we're entering these 2 numbers, a 5124 for the first one and a 5112 for the second one. And again, the numbers in red are what change, and the under numbers stay the same for these commands. Now the link command, in these commands, if you're not familiar with the mini panel, or maybe you're not even familiar with DCC that much, they still should seem sort of logical because they're pretty much plain English with the exception of a couple of them. The link statement is basically just tells it to link to a different place in the program. It's like a go-to statement in BASIC. Like for here's an example, link to input 9. That just says go to step 9 and do whatever's at that memory location. The fourth one is the end statement or terminate statement. That's a 571. That just means stop executing commands. Fifth is a no-op command. That means no operation, do nothing, go to the next step. It's just if you want to put it in an empty location, you're not using it. It just is a safe way to take care of an empty location. Memory command number 6, select the logo 3. In this case, we're asking it to select logo number 3. And my one logo is a number 51, so I have to enter an 051. I have to make sure I enter an 051 when I select that logo, and I need to look for an asterisk, which apparently indicates the long address is selected. The next command, speed forward 10. In this example, you're basically telling the logo to start up and run at a speed of 10. Now this next command is one of the less obvious ones, but we're using it here. It says skip if input 16 is open. In other words, what it's saying is skip the next command if read switch 16 is open. And this is used in the testing read switches. It's not used in the program that runs trains, but it's used in the part we use to test read switches. The ninth command we use, wait until input 16 is grounded. That's saying wait for read switch number 16 to be closed. There's the resistance decreases. It goes almost to 0 when the read switch is closed. We're using these statements both for read switch 14 on the main line and 16 in the yard, just to find out when the train gets there. Essentially, the magnet on the bottom of a car goes over the read switch, which closes it, and then this wait statement will proceed to the next statement, but it'll sit and wait until this condition is satisfied. Now 10 and 11, again, these are less obvious macro commands. They're basically, we use macro 14, which says set both turnouts straight, macro 15, which set both turnouts curved, and the macro is in the command station, not the mini panel. So if we would take this program to another command station, we'd have to remember to set up the macros in that new command station or it wouldn't work right. And basically the macros allow you to combine several accessory commands. Down here, like accessory 7 norm, that means set turnout number 7 straight. And the one here on the end is the specification for straight. The 7 is the specification for the accessory number. And we can also have an accessory 10 reversed, and that means turnout number 10 or accessory decoder number 10, 2 is reversed. So that says set turnout number 10 curved. Again, 1 is straight and 2 is curved. And this is what I normally use as these commands, but in this case, I was running out of space in the mini panel, and by using the macro commands, I could use one command to set both turnouts curved or set both turnouts straight rather than 2 commands. So just saving a line every time we needed to throw the switches, it made it possible to put a little more in the mini panel. And there's another skip command. I've just documented it here. The opposite of the above one. This says skip if input 16 is grounded. And in other words, it says skip the next command if the read switch is closed. We don't use this one. I just put it here for reference. If you're not familiar with the operation of this mini panel, you might find it interesting to see what a few of the commands look like when viewed in the from the mini panel. What we've got here is an old ProCab plugged into the programming port of the mini panel, and we've got 3 options set up, which is what we use to actually program it. Test operations, which is what we were using in the video to execute some of those routines, and then 2 is review, which it just allows you to look at what's in the mini panel. We'll press the 2 button down here on the keypad to say review, and we're going to press it again to review input 2, which is what's over here on the paper. You can see, so I'm going to push a 2 and hit the enter key. And you can see it says input 2, step 1, select loco 3364. And you can see where my pin is on the right. That's what's on the paper. We'll go to input 2, step 2, speed forward 22. And again, it looks pretty much like what's on the paper. Input 3, wait till input 14 is ground. Again, like the paper. And input 2, step 4, delay a quarter second times 4. Well, the paper says delay a quarter second times 12. I've got it set for a shorter delay to have the trains running more often. This is mode 2B, as I've shown here, I believe. And this one over here on the paper is mode 2A, but just timing differences. If we go to the next, now we're at input 3, step 1, and macro 15. Input 3, step 2, select loco 1216, again matches the paper. Speed forward 13. Input 3, step 4, select loco 3364. So you can see the commands actually in the mini panel pretty much closely match what's on the paper. It's easy to understand what you're doing pretty much. I've been using the enter button, which is down off the screen, to go forward a step. There's input 3, step 4, input 4, step 1, and push it again, input 4, step 2, and so on. Now we can also use these increase, decrease buttons to go up or down. If I push the decrease, it starts going backward. It's input 4, step 1, input 3, step 4, input 3, step 3, and so on. So these buttons allow you to go forward and backward. And likewise, these increase fast, decrease fast buttons, which normally go 4 speed steps at a time when you're controlling a train, when you're using it for programming, they'll jump you backward or forward to the next input. If I push decrease fast, it goes back to input 2, step 1. If I push it again, it's back to input 1, step 1. And you can also use the thumb wheel to scroll forward or backward in the commands. We've got some additional documentation on page 3. What's shown down below the library is the cycle times, and we just made a note there's a complete 6-part cycle. That's where the trains go through their 6 subsequences and get back to their original position. Takes about 3¼ minutes with the minimum delay, and about 5 minutes with the maximum delay. There's minimum delay is when we have 2 trains on the track as much as possible. Maximum delay is when we have 1 train running and 2 trains stopped as much as possible. That maximum delay is when we move the virtual location of reed switch number 14 all closer, more downstream, closer to where the yard is. So you see 1 train coming in the yard right after the other one is pulling out. And the delay after reed switch number 14 we set for 3 seconds nominal, about 15 seconds maximum, and 1 second minimum. And to change this timing between the trains, we change the delay commands. Actually, this is input 2, step 4, input 4, step 4, input 6, step 4, and correspondingly inputs 8, 10, and 12, step 4. There's 6 places we have to change that value of that delay command. That makes the train in the yard pull out sooner or pull out later. And some more documentation, what inputs were used for what routines here. This is something subtle about the mini panel. We've got like roughly 30, I think technically 31 inputs that you can hook push buttons up to, or reed switches, or electric eyes, and probably other things, that you'd either ground or go from open to ground, or go from ground to open in the case of an electric eye, that signal the mini panel. But you can also use those inputs for memory. and each one of those inputs has 4 steps. So with 30 inputs, you've got, in theory, 120 steps total, or you could put, in theory, 120 commands. And in practicality, you can't, because you've always got to have some empty steps. Like when you do a link statement or something, you end up with some steps you can't use. But anyways, this is a documentation of what's in the mini panel. 2 through 14 is the 3-train operation. 15 through 18 is the read switch testing. 19 through 23 is the automatic passing siding operation with 2 trains. 24 through 28 is the automatic, one of these should say automatic block. This is an error here. One of them, this is the automatic block right here, 24 through 28. And then inputs 29 through 30 is the automatic station stop. And again, a couple more notes. We're using inputs. This has been already said, but we're using input 14 for the mainline read switch, input 16 for the siding read switch. And these kind of correspond to T2 and T1 in the old 1992 videos showing the relay systems. We call them T2 and T1 in those videos. Now we're on page 4 where the commands actually start. The first thing we got in input 1, that's our push button, labeled here button 1 test read switches. Input 1 is our push button to go test the read switches. So we got one statement here which is linked to input 15, and down there is the program for the read switch testing. And then we have end statements, and this is an example of where you can't use these steps because you're using you're doing a link statement in the first step, and the steps 2, 3, and 4 is basically space you can't use for anything. And in input 2, that's button 2 3-train operation. We call that mode 3. So if you push button 2, it will start executing step 1, which is selecting this loco. And incidentally, you may recall back earlier in the configuration, we said ignore inputs 3 and above. So when this mini panel is idling, when you first start it up and it's not doing anything yet, it's continually looping around here, I assume, checking input 1, then input 2, then input 1, then input 2, checking to see if anybody is pushed a button or somehow grounded that input that notifies the mini panel to do something. But it won't check inputs 3 and above unless specifically asked to, like inputs 14 and 16. It checks those only when there's a statement that says look at that input. Anyway, so if we push button 2, that starts our routine, and these sequences here are numbered. I put statements in that link to the sequence drawing, sequence 1A, 1B, 2A, and 2B, which is kind of off the bottom of the screen here. But if we look at this part of the sequence diagram, I can get it on here. Here's 1A, 1B, 2A, 2B, and they correspond to these statements here. So let's just look at the first one, 1A. The first thing that happens when you push button 2, it selects loco 3364. That's the orange one on the diagram, the Jeep. It starts it up at speed 22. Now here's a wait statement. Wait till input 14 goes to ground. In other words, wait to read switch 14 on the main line. That's over here. We're waiting for this loco to cross over that green read switch. And when that happens, we're going to delay a quarter second times 12. In other words, a quarter second times 12 gives us 3 seconds. That's our nominal delay. That was the first demo we did in the main part of the video where I was talking. Kind of an in-between. We have 3 seconds delay. And we can set that to 4, which will give a 1 second delay to have 2 trains running as much as possible. And we can set it to 60, which is a 15-second delay to have only 1 train running. And that's where you saw this was mode, I believe, 3C, where the train coming into the yard was almost chasing the one leaving the yard because we had a lot of delay, which started the one up in the yard later to the point that the one on the main line was almost entering the yard at that point. And again, these delay times are the same at step 4, input 4, and step 6, 8, 10, and 12, all input 4. So our next command, and we're down now to this is 1B. It's covered up here. Not quite. We're going to set both turnouts to curved. Then we're using the macro 15 to that for setting both turnouts curved. Then we're going to select logo 1216, which is the shark nose diesel, and then we're going to start that diesel. So when we do this input 3, step 3, speed forward 13 on the shark nose, which is 1216, that starts that loco up to leave the yard. That's shown right here. This in the shorthand notation we say speed 1216 equals 13. We're getting that loco moving out of the yard. So going down right to here, we've done everything shown over here in sequence 1A. So now the next part essentially is sequence 1B, which is stopping this engine, this orange engine as it comes into the yard. We got to get that stopped. So the sequence 1B will take care of that. And that says select logo 3364. That's the orange one, which is the Jeep. And then wait for input 16 to go to ground. That means wait till the reed switch 16 in the yard is closed by the car with the magnet crossing over it. And then once that happens, we send a speed forward 0, or to set speed 0 command. We're telling the loco to go a speed 0, which is essentially stop. We're saying stop that Jeep, so it'll pull into the yard and stop. Now our shark nose is out on the main line, and I think we're back. Yeah, we're ready to start sequence 2A, which starts right here with the shark nose on the main line. So we're saying wait till input 14 is grounded. That's wait till it reaches input reed switch 14 on the main line. That's up here. We're waiting for this blue shark nose to go over reed switch 14. And then we're going to, again, delay 3 seconds before we change the turnouts. And again, this has to be at least enough delay that this train coming in the siding, I don't show the cars here, but there's cars in the caboose. That 3 seconds or whatever delay you're using has to be at least enough that this train gets in here, gets across the reed switch, and gets the last car out of the turnout, because you can see if the turnouts are thrown before this train gets clear of the turnout, there's going to be a derailment. So, but 3 seconds works fine. Delay 3 seconds before changing the turnouts. Then we're going to set both turnouts straight. Then we're going to select logo 51, which is the train master. That's this one right here shown in purple on the diagram. And we're going to start it up at speed 17, which is going to start getting it out of the yard. And that's the end of sequence 2A. We have a note here, 051 exits the yard. That's the train master. Now let's bring up sequence 2B here, as much of it as we can. So we'll scroll this thing up here. So now we've got the train master running on the main line, and again we're just repeating these statements again, except with different engine numbers. Waiting till input 14 goes to ground. That's waiting till the train master reaches the number 14 reed switch, and then when that happens, delay, set both turnouts to curved, select the Jeep, which is sitting in the siding, and start it up. And that's the end of sequence 3A. We've got the Jeep basically starting the Jeep up, and it takes off out of the yard. So when we get to sequence 3B, it'll be out here somewhere. And in sequence 3B, we're going to select the train master 051. That's right here. We're waiting for it to come into the yard. Wait till it reads switch 16 in the yard. That's right here. When it goes over that read switch and the magnet on its first car closes a read switch, we'll send a speed forward 0 command, which tells the loco go to 0 or stop, in other words, and that'll stop the train master. And at that point we'll be looking at this point like this. These two engines will be in the yard, and the rest of this command file is basically repeating all those sequences, just changing engines around. And when you get down to the bottom here, where you're over to sequence 6B, and it issues the last stop loco command, then we link to input 2, which goes back to the top and starts repeating everything all over again. Just a couple more points about this system. Let's talk about if you had to change a locomotive. Let's say you have this blue shark nose diesel here, which is this number 1216. I believe this appears in the 4 times in this sequence. So if you took number 1216 off the layout and replaced it with a different locomotive, you'd have to change this. You'd have to change four lines of instruction, the 4 places where this 1216 appears. Here's where it started up once, and then down here it's stopped here, and then I believe it appears 2 more times down below. So the other option, if you put a different locomotive on, would of course be just to set the new locomotive's number temporarily to 1216. And the other thing I wanted to mention was the sequence for going over these read switches. I think this was mentioned in part 1 somewhere. The way this is programmed, like going up here to the left where the sequence diagram is, the orange engine, the Jeep, goes over this read switch, the 14, and the next thing that happens is it goes over 16 and stopped. And then the next thing that happens is the shark nose, the blue one, is out on the main line, and it goes over read switch 14. And you've got to make sure that there's enough delay between when this engine goes over the read switch and before the shark nose gets there. This engine has to get in and get across that read switch. In other words, said another way, if this shark nose reaches this read switch before this engine reaches this read switch, the thing will be out of sequence and you'll have a wreck. And if you look at those read switch crossings over here, let's see, there's where the shark nose is started up. And then, well, we got to go up a little bit here. Select local 36. They were waiting for it to go across read switch 14 on the main line. This is the Jeep 3364. And then we select the shark nose and start it up. And then we wait to reach, now we go back to 3364 and we wait till it goes into the yard. So there's the second crossing of a read switch. And then we select and then we wait till the shark nose on the main line reaches read switch 14. So those crossings of the read switch have to appear in the proper order. So if you get too short of a delay between when this crosses the green read switch and when the shark nose it gets pulled out onto the main line, they could get out of sequence like that. So, but you control that just by increasing the delay we've been talking about. You make a long enough delay that you make sure that this engine crosses into the yard and gets across that read switch before the shark nose gets out on the main line and crosses that read switch number 14. The rest of this video, we'll go over the commands to test the read switches, and then we'll go over the commands to do the 2 different modes of two-train operation, automatic block and automatic passing sighting, and then finally we'll review the commands used to do the single train automatic station stop. Thanks for watching. this metal piece of metal here. So I'm going to bring that magnet down next to the reed switch, and you can see what's happening. Both those reed switches are flipping about a second apart. Now that was reed switch number 14 on the main line. If I go back here, here's the routine for testing the reed switches. We had 2 reed switches on our little layout. Number 14 out on the main line right about here, and then two reed switches we called number 16 in the sidings right over here, and these two are wired together. So there's 3 reed switches, but they're only going to 2 inputs on the mini panel, input 14 for this one and input for 16 for this reed switch over here. And for our testing the reed switch routine, we wanted to set it up so that we could hold a magnet over any one of these 3 reed switches, and the mini panel would acknowledge that by throwing the turnouts approximately once per second. So that tells us the reed switch and the mini panel and the turnouts are all communicating. So looking at the commands for that occurs in inputs 15 through 18. In the first part of the commands up here, the first 2 inputs, that part tests if a magnet's closing the reed switches. And then down here where it says change turnouts, that's the commands that actually throw the turnouts. So looking at the top part, if there's no magnet near any of the 3 reed switches, they'll all be open. A reed switch is normally an open circuit unless a magnet nearby causes it to close. So let's assume for the moment they're normally open. The first thing when we actually push button 1, if you recall back at the beginning of this command file, when you push button number 1 to start the reed switch testing, it says says link to input 15, which brings it up here. And this looks at input 14. It says skip if input 14 is open. If there's no magnet, it's going to be open, so it's going to skip the next line and go down here to this step 3. And then this command says skip if input 16 is open. And again, if there's no magnet at reed switch 16, it'll skip that statement. So it'll end up down here at this statement, which is linked to input 15, which takes it back here. So what happens if there's no magnet near any of the 3 reed switches? This thing will just keep looping between the statements in input 15 and 16. Now, if let's say, for example, there's a magnet over reed switch 16, which is the one in the yard. So let's look at it in that case. In that case, input 16 will be closed. So in that case, it'll come in, it'll encounter this statement, skip if input 15 is open, and it will be, so it'll skip the next statement. But it'll encounter this statement, skip if input 16 is open, but that'll be closed if we're holding a magnet over reed switch 16, and that'll take us to this link to input 17 statement. So it'll go down here to these 2 sets of commands, which will actually flip the switches. So now here I don't have the macro statement, I've got the actual accessory statement in here, but this says accessory 10 norm, which throws the rear turnout to straight, delay a quarter second, and in reality you can't even detect this quarter second. Then it says accessory 7 norm, throws a front turnout to straight, then it'll delay about 3/4 of a second, then it'll go back and set a accessory 10, which is rear turnout number 10 to curved, set the front turnout to curved, it'll delay a second, and then it says link to input 15, so it'll go back up to the top here, and assuming we're still standing there with the magnet over reed switch 16, remember this is all took only about a second, it'll do the same thing, it'll skip this statement, but input 16 will be closed, so it won't skip, it'll encounter this link to input 17, go down here and flip the switches again. So let's look at the other possibility that we're holding a magnet over reed switch 14 on the main line and not reed switch 16. It'll do almost the same thing up here. it'll come in. Now this, if this is closed, it won't skip. That's saying we're holding a magnet over read switch 14, so that it'll be closed. It will encounter this link to input 17 statement, so it'll go down here and do the same thing, flip the switches to straight, and then flip the turnouts to curved, and then it'll link back to input 15 and do the test again. So this sets it up so that if any of the read switches have a magnet over them, it'll flip these turnouts once per second. And this is basically, I guess you can consider this an OR condition. It'll go down and do this flipping if 14 has got a magnet next to it, read switch 14 has a magnet next to it, or if read switch 16 has a magnet next to it. We wanted to do it, if either read switch has a magnet next to it. Here's mode 2A, automatic block operation using 2 trains as seen on YouTube for part 1. And basically our go point is right here. You can see when the train goes over this point, it releases a train stopped in the siding. And we're just using the 2 read switches to operate this. The turnouts are not being used at all. You can see this train master is parked over here and the turnouts aren't operating. Now we'll take a look at what we call mode 2A, where we operate 2 trains in an automatic block mode. And this is distinctly different than modes 2B and 2C as demonstrated in the video. Modes 2B and mode 2C were automatic passing siding operation where we were using trains on the sidings. For this automatic block operation we're going to talk about now, we're not using the turnouts at all. The turnouts are set to curved and they stay curved the whole time. The train on the outside siding just stays parked there. If we look at the sequence diagram for this, it basically works the same way as the 3-train operation, except you're not using the switches to alternate trains coming out of the siding. So you're always bringing the same 2 trains in and out of the siding. But initial conditions, if we have the blue engine here, which happens to be the shark nose parked on the siding, and we've got the orange engine running on the main line, we'll wait until it goes over read switch 14, and at that point we'll start the blue engine up out of the siding. That's a shark nose, that's a speed 1216 equals 13. So when this orange engine crosses this green go read switch number 14, it will send a command to the shark nose to start it up, so it'll start leaving the siding. That's part A1 of the sequence. And then part A2 shows the shark nose has left the siding, is out on the main line. Meanwhile, this orange engine is coming into the siding. We're going to wait till it goes over read switch 16, and we're going to send a speed 0 command to it, which will stop it. So when this engine reaches the red read switch, it'll get a stop command and it'll stop in the siding. At that point, it'll look like this drawing, which is we're calling a subsequence B1. Now we've got the orange engine parked in the siding and the blue one is out on the main line. And now same thing all over again, except it's just different engine numbers swapped around. We'll wait till this 1216 hits the green read switch, and then we'll start the train up in the siding, which is 3364. That'll start the orange one out of the siding. Now going down here, now the orange train's back out on the main line. The blue engine has come around, is entering the siding. We'll wait till that one crosses number 16 read switch, the stop read switch, and we'll send a speed 0 command to the blue engine, which will stop it onto the siding. And at that point, we'll be back up here at the top, the subsequence A1, and we'll repeat the thing all over again. So we can looking at the actual command file again, these 4 subsequences, A1, A2, B1, and B2, they're marked on the command drawing to match what's on the sequence diagram, but here's basically the same commands all over again. Macro 15 just sets both turnouts curved, and they always stay curved the whole time. We never send a command to set them straight. So this selects the orange loco 3364, starts it up, and puts it on the main line, and we're waiting for input 14 to go to ground, which is the green read switch. This is just a dummy command that gives a blink on the mini panel when the engine goes over read switch 14. It's marked here. It says just a dummy command to blink LED. It's really saying set turnout number 2000 straight. Well, there is no turnout 2000 on this layout, but the mini panel will blink when it sends that command. So we're going to delay, in this case, 4 seconds before we start the other loco. And this delay command can be adjusted the same way as we were talking about adjusting the delay command back in the beginning of the video for 3-train operation. You can use this delay command to pull this train out of the siding sooner or later, depending on how you set the delay. So at any rate, we're going to select the 1216 loco, and now we're starting sequence A2. We're going to start it up, which is going to pull it out of the siding. It'll be about like shown here. Now we're going to select 3364, the orange one, that's over here, and then we're going to wait for it to cross read switch 16 in the yard, send a stop command to it, speed 0. So at that point, that brings us down to sequence B1 right here. We've got the orange train sitting stopped in the yard. The blue engine is out on the main line, so we'll do the same thing all over again. Wait till input 14 is on the main line is grounded, send a dummy blink command, delay 4 seconds, and we'll select 3364, which is the orange one here, send it up speed command to 22, which will start this engine pulling out of the siding and put it on the main line. That brings us down to subsequence B2, where at this point, now we're going to select 1216, the shark nose, that's over here. We're going to wait till it reaches read switch 16 in the yard, send it a stop command, and then we'll go back to input 24 at the top and repeat the sequence again. And notice there's actually a couple of duplicate commands. We started 3364 up and give it a speed of 22, and it's doing that, and then it's coming up here and telling it to do it a second time. So actually we're repeating that command twice. It doesn't hurt anything, but you can't link to an input and a step. We could actually link to, if we could say link to input 24, step 4, we could come up right here to this line and skip these top 3 commands, which we don't need anymore, but you can't do that. So we just come up to the top and let them repeat. Just for review, here's a look at part 1 on YouTube, and this is mode 2C, automatic passing siding with multiple laps around. You can see the Jeep is parked on the spur off of the line, and we're using the siding to alternate between 2 trains. And as you see it operating here, they're each doing 2 laps each using the turnout. So you can see the train master just started up, and that'll make 2 laps around and then stop, and the shark nose will make 2 laps around. And as mentioned before, you can use a delay statement to control how many laps you want to make. 1 lap, 2 laps, 3 laps, or 4 laps, and you can control it individually for each train. And there's another delay statement that controls the delay of how long they sit there on the siding. So this is again a review of mode 2C, automatic passing siding with 2 trains. And we're just using the read switches in the yard for this. The read switch on the main line isn't necessary for this. Now we'll look at what we called modes 2B and 2C, where we ran 2 trains in an automatic passing siding type of mode, and 2B was just 1 lap around each train, and 2C was 2 laps around for each train, but basically the same thing. And let's look at that over here on the sequence diagram And the third train, the Jeep, we had parked off on a spur, so it's got to be off the main line. We're just using the in the video the blue shark nose and the train master on the outside siding. And this is probably the simplest sequence of all these sequences you see in the video. This is very easy to do with a mini panel, but basically we start the blue one up and have it go around. And that the commands for that is we basically just set the turnouts curved, and then we send a speed command to 1216, the shark nose of 13. That gets it out traveling on the main line. Then we wait for it to go around the loop and come back in the siding. And at that point, we're gonna wait till it crosses read switch number 16, our stop read switch. We'll send a speed of command to 0, and it'll just set speed 0 command to that blue engine when it goes over the read switch, and that'll cause it to stop. And then at that point, we'll set the once this blue engine, the shark nose, comes in here and stops. That'll, as we mentioned, that'll start the purple engine, which was a train master. That'll start it up, and it'll go around the loop and come in the other end. And at that point, things will look like this last part of the diagram. We'll have the blue engine stop, and the train master will be coming into the siding. And at that point, we're going to wait until the train master goes over the read switch 16, send it a set speed command to 0. We'll delay 2 seconds. That's the time between trains. Then we'll throw the turnout curved, and then we'll send a speed command to 1216, the shark nose, to start up. And at that point, the sequence is repeating itself. In this, S, O, and I is for start, S for start, O for outside, and I for inside. Now let's go take a look at those same thing in the command file. What we've got here at the beginning, this uses inputs 19 through 23 as written. We send a macro 15 command, which sets both turnouts to curved. Then we select 1216, that's the shark nose, and notice this is marked as sequence S for start. And then we send it a speed forward 13 command, which starts it up. And now here's our delay. This is shown for 2 laps around. We delay for a quantity of 20 4-second delays, which gives us 80 seconds. So that means we basically tell the mini panel to wait for 80 seconds before you do anything. And while the mini panel's waiting, the train can be circling multiple loops. We can make this longer to get 3 laps, still longer to get 4 laps, and so on. If we set this to 2, like we showed in mode 2B, that would give us 8 seconds. That'll just take 1 lap around. But as the command file is shown here, we're using 80-second delays to have the engine go 2 laps. And there's a note here, 80 seconds results in 2 laps. And then we send a dummy command here. This just blinks when that times out. If I watch the mini panel, I can tell when that delay command ends, and at that point, the next time the train comes in the yard, it should stop. And we're waiting for input 16 to go to ground. That is to say, we're waiting for it to cross read switch number 16, and that's the beginning of sequence number O, the outside sequence shown right here. So we're going to stop that train, which will be the blue train. We're going to delay 8 seconds between trains, a quarter second times a quantity of 8. That gives us, that gives us 2 seconds between trains. So we're basically stopping and pulling the other one out. But we can actually change this. This is important to note. We can change this. We can make this delay longer if we want to hold like the trains for 20 seconds between trains. We can just make a bigger number in here. So at any rate, we're ready to run the outside train, run the outside track is our note here. We're going to send macro 14, which will set both turnouts straight. That'll enable us to run the outside track, start up the Loco 51, which is the purple train master on the drawing here. Give it a speed command to get it going, and again we'll delay 80 seconds, so that train will make 1.5 laps. But you can adjust these individually. You can have one train go 1 lap, the other train go 3 laps, or any combinations of trains and laps. And again here we're sending a dummy command to blink the LED when the delay statement times out. Now we're watching read switch 16 for that train to come in the yard, and when it does, we're going to send it a speed command to 0. So that's right about here in the sequence diagram. We're ready to stop this train, and again we'll delay 2 seconds between trains, as you saw in the video. And again, this number can be increased if you want a longer wait between those 2 trains. And it says link to input 19, which basically takes it back, and you start all over again and repeat this operation. And this is very easy to. Like I said, the mini panel does this very well. There's no timing issues because one loco is sitting completely parked. In this case, over here, shown the purple one's parked, and it waits till the blue one gets around and gets stopped. And the blue one can take its good old time. It doesn't matter how long it takes to get back there. Then the purple one will start out next. So, and you can very easily extend this to 3 tracks or even 4 tracks or 5 tracks. Video number 812 demonstrated doing this for 3 tracks using large-scale trains. This is just for review. This is a look on YouTube at part 1, showing mode 1B, automatic station stop for just 1 train. You can see the Jeep is still parked over on the spur here, and the shark nose is basically out of service on the inside track. So we're just running the single train, the train master. And as you're seeing it here, it's making 2 loops around before it stops. And there's a delay statement. Again, you can adjust the delay statement to control it to make 1 loop, 2 loop, 3 loops, or 4 loops. And there's another delay statement you can use to control how long it sits in the yard here. Now it's set for a very short time, so it takes off almost immediately. Finally, we can talk about the last mode of operation that was shown in this video, what we called mode 1B, or a time station stop for 1 train. We were defining mode 1A as 1 lap around, and we didn't demonstrate this since it's such a simple operation. And we called mode 1B multiple laps around, which is what we did demonstrate in the video. But again, here we shown on our sequence diagram, if we used the Locomotive 51, which was the train master for this, and we had the Jeep again was off on a spur to get it off at the main line, and the blue shark nose was actually parked on the inside siding, but we didn't use it at all. We just used the outside siding, hence there's no turnout shown here because we're not using the turnouts. But if this engine's sitting here and we start it up with a speed of 17, it'll go around the loop, and we can, if we put a delay statement in there to make it run multiple laps, which is what we did in the video, it'll go around the loop 1 or more times. In the video it was 2, but it could easily be 3 or 4 times. And then when that delay statement times out, we'll be down here to part 2 of this, and we'll wait till it crosses over read switch 16, the stop read switch. At that point, we'll send it a speed 0 command, in other words, a set speed 0 command, which will bring it to a stop, and then we'll delay for 10 seconds or however many seconds we want to have our station stop before the train starts up again. And if we look at this sequence in the command file, we basically start out with a macro 14, which sets both turnouts straight, and again, we never change them to curve. They're straight the whole time. We select our Loco 51, the train master, start it up speed 17. Now, as shown here, it's delayed 15 times 4 seconds, which gives you a 60-second delay, and that allows 2 laps. But again, you can make this a bigger number to have 3 laps or 4 laps. Now, after this delay statement times out, we put in a command, wait until input 16 is ground. That's wait till the train crosses over the read switch number 16 in the yard. At that point, we send a speed command to 0, which will stop the loco. Then we delay 20 times a quarter second, quarter times 20, which gives us a 5-second delay while the engine's sitting in the yard. And again, we can make this delay statement bigger to make it longer, to hold in the yard longer. Then we finally a link to input 29, which will take it back up to the top and keep repeating this. And this is basically the end of the programming area for the mini panel. There is one more input, 31, but this is, I believe, this is one that executes commands automatically upon startup, and I stay away from this because for the things I do, I don't want the mini panel starting up automatically. I want to start it up when I push a button, or in the case of this video, go in with my in program mode and tell it to start.